All right, Jim Hatcher, welcome to the Big Ideas in App Architecture podcast. How are you doing today?
I'm great, David. I'm honored to be here.
you know, for anybody else who's coming to the podcast, I would have to spice this up a little bit. But because you're here, I don't think I have to do much because the conversation with you has always been so easy for me. So for people who are listening in, Jim and I go a long way back, not like super long, but I've known Jim since 2018, I believe, and the history lesson there for everyone to know is like Jim was one of the people who interviewed me for one of my previous jobs, and then I was so scared leaving the interview. He was the one dropping me by to the left, and he's like, "You did good." So that's when our friendship began, and I am super stoked, man, to have you on. So I hope you had a great day and you're excited to be here.
Yeah. I've seen so many episodes of this podcast, and I thought, when is David going to ask me, the guy that helped him get that job, onto the podcast? And here
It is true.
It's
It
happening.
is true.
It's a magical day.
Yeah, I mean, this is for the universe. This is me paying Jim back by giving him some LinkedIn brownie points by having him on the podcast. Yeah, yeah, and it's amazing, man. So how's your day been? I know this is December. Are you like getting ready for Christmas? And it's been a fun year for you.
Yeah, good year. Yeah, week or so before Christmas, so a little lighter on meetings than I normally am. So I'm getting a lot of stuff done that I've been meaning to do for the past, couple months. Stuff that I wanted to get done. So that feels good. I feel productive.
Yeah, it is. It was inevitable for me to do a podcast and not to have you on here ever. I mean, so it's great to have you. So for everyone listening in, Jim here, Jim works with me here at Cockroach Labs. This is our second stint working together at a company. Jim has always been a pioneer at finding better jobs than me, so he is always ahead of the curve, and I've followed him. But Jim, without me butchering your intro, apart from everyone getting to know that we are pretty good friends, tell us a little bit about you and your career and what you do at Cockroach Labs.
Yeah, sure. So at Cockroach Labs, I'm a solutions engineer, which means I'm involved in the sales process, but I'm the technical guy that kind of gets to tag along with the sales guy, and so I answer questions about how the technology works, and I get to understand the use case that people are wanting to solve, and are usually evaluating a product in order to solve. So I like that part of that job. It's a lot of problem solving and working with people and trying to understand what they're doing. But I haven't always worked in sales. Most of my career, I was a developer and an architect, and I started off like working on kind of small systems, and over my career, worked on bigger and bigger things. And then at one point, I thought, hey, I'm gonna take a little detour here and work for a software company and see how that goes. And that's been a good change, a good turn in the road career wise. I enjoy it. So
yeah, and that's how you got to meet me too. Yeah. So how many years have you been in the tech space now?
I graduated college in 1999. So was that 25 years?
Wow, that's awesome, man. Yeah, so it's so much has changed in those 25 years. I mean, from like the era where we would make websites to apps, and now large language models and AI. It's been a fascinating 25 years, obviously for you, and we're going to get into all of that. And tell me, was there like a particular moment in your life that you were like, oh, I've got to do tech. that's what I'm called to be.
Yeah. In high school, I was in a band. I played guitar, and I thought I really like playing guitar, and I want to do music for a career. And but I'd also kind of get into computers, and so I went to college, and I thought, you know what, I'm going to double major in music and business. And so I was enrolled as a music student, studying music theory, and then I also got into a business degree studying computers. And a couple of years into kind of doing that double major thing, I thought, you know what, I'm not sure how I'm going to make a living as this musician thing. And so maybe I should switch gears and do the computer thing. And I yeah, I think that was a good decision. I remember a couple of classes I had that really impacted me, and I was like, "Oh, I really like this." I think the one that really stands out is like the database class I took. I remember like when we started learning about how database modeling works and foreign keys and some of this stuff, and I like had this like kind of a hallelujah chorus moment. I was like, "Oh, I really like this," and so I've always kind of liked working in databases, and um, even as a developer, I always kind of leaned towards being like a dev DBA. So
Right. Yeah, and that's the era when we would call somebody a dev DBA over a full stack developer, I think. So, but this is not the first time you have mentioned this to me, because in the past you have told me, like, we have talked about, like, why don't do Kafka, and you're like, I don't like pipes. It's like, so I mean, it's so clear that you've always been somebody who's passionate about data and databases, and pretty much now that now you work for a database company, which is sort of like a different type of database. Like Cockroach Labs and CockroachDB is a distributed SQL database. And when you started your career, you're basically doing relational traditional databases, right? And in between, I think you have gone through every era. You've been at a NoSQL company and over here. So tell me a little bit about how your experience has been working in an environment where your career has been shifting, dealing with different technologies, like things that were relevant in 2005, 2015, and stuff like that. Yeah.
yeah, I was thinking about that recently. Yeah, I guess I'm a guy that if you look back at people you worked with over the years, I think you could split them into two categories, like people that think there's code and code's the main thing and the database sort of supports the code, or people that are like, it's all about the database and the code just supports the database. I've always been in the latter camp. Like anytime I've sat down with somebody to design a system, I'm like, okay, first thing we're going to do is build an entity relationship diagram, and understand the data, and then we can build an app around it, But yeah, I was thinking about my career, and early on in my career, like my first job was I worked as a tech support person at the college where I was going to school. I like started to work full time before I had graduated, and so I worked as a tech support, and my boss was like, we don't have like a ticketing system or anything. Do you think you could build a little application that you could use to track tickets? So I was like, okay, I'll do that in Microsoft Access, So we spun up an Access database and put it out on a Novell network drive somewhere, and that was kind of my earliest database thing. And then I think as you move through your career, you you start on something small, maybe working on departmental things or line of business things, and then you kind of grow into bigger systems. So like in my career, I went from doing stuff in Microsoft Access to then Microsoft Access is kind of good for these little tiny things, but it's not good for like a real app. And so I moved on to SQL Server, and I think SQL Server I worked on like SQL 6.5 and then 7.0. I got real into it about 7.0, which is probably like 1999, I guess. I don't know, 1998, something like that. And yeah, and then I think some of the early systems I worked on, they were like departmental, and so you'd spin up a SQL Server in a lab, and maybe you'd have a backup, maybe you'd have a some kind of redundancy. But and then as I worked on bigger and bigger things in my career, you start to think about what happens if this data center goes down. What happens all of a sudden if you're working on these mission critical things? So I was thinking recently in 2008, I think I was working at Western Union, and we were building a fraud detection system that got used on westernunion.com. So westernunion.com, you can put in a credit card number and say, I want to transfer $200 to David Joy, and it charges that credit card number and sends the money to David Joy. And so there's a huge fraud problem with that, because you can go steal a credit card and then say, I'm going to give it to David Joy, and then David Joy picks up the money, and David Joy's my collaborator, and we go and split the money or whatever. I mean, it's like a very easy system to defraud. So I worked on the system to kind of detect fraud there, and so it was mission critical thing and had to be up all the time. And so I can think like we had to design the system and say we need this many app servers, this many database servers, and then we'd sit down with the infrastructure guys and they'd say, okay, we need this many servers. We're going to use Dell, blah, blah, blah. We're going to put those in the data center, but oh, we don't have room in the data center. So we got to, figure that out. Or, oh, we know we've got room, but there's not enough power. And you're like, not enough power. Like, and then they'll say, hey, we've ordered the machines, but they're on back order and they're going to take 3 months to get here. And then they finally show up and they're like, okay, they're on the dock and I've got to get them. I got to run over to the data center and like rack the servers and like get them installed. And that's going to take me 2 weeks. And, but eventually it would get all that set up. And then, but you're running against a SAN because, you don't want to have locally attached disks because then if a disk goes out, somebody's got to go change it. But, so a SAN, you run over the network, but back then Ethernet networks weren't very fast. So you had to hook up fiber channel and you'd have a SAN connected to your box over a fiber channel. And, I was just thinking like that was like state of the art back then. Like that was how you ran like this mission critical system. And so much has changed. I was thinking like what are all the trends in technology that have sort of washed through? And so I think about virtualization. I remember when I first started hearing about VMware and like we've got all this wasted capacity in the data center.
When did you first hear about VMware? Was it 2004, 5?
I think it was probably maybe 2009, 2010.
Yeah, I think that's when it got a little bit more mainstream. But I know they were working on that for like since 2006. But I'm just curious when you got into it because I got introduced to VMware pretty late, like 2014. So
yeah, I remember when we first did it. The name of the game was you could virtualize your app servers, you could virtualize like your web servers, but you didn't want to virtualize your database servers because they didn't really have I/O figured out then. So we would run like virtualized app and web servers, but then the database servers would be bare metal. And we just crammed those database servers full of like much memory as we could get. And, but a few, 2 or 3 years after that, you just virtualized everything. And then, once we started hearing about virtualization, then I remember the first time I heard about cloud, I was like, what is cloud? This sounds fancy, and just kind of like taking that virtualization concept and moving it to the next level. And, now to think like, oh, I got to work on a system. So we got to figure out like what kind of Dell servers we're going to order and like put in a physical order to get those into the data center. Like, nobody does that anymore. I don't think
it's just available. Yeah.
Yeah. So, yeah, I mean, I think it's interesting to think like what is modern, and I can remember always thinking like you'd hear about like, oh, that's the legacy system. Like there's the new system and there's the legacy system, which is sort of like it's like a not much of a compliment to say you're the legacy,
Yeah. I mean, it's when you say that, when you're saying modern, right? It's so funny. The problem is the times, whichever time we live in, we call that system modern and everything else legacy. Like in 2010, virtualization was modern. So they would go to everyone saying, oh, let's move to these modern systems. And then in 10 years, we're like, oh, Kubernetes and containers, those are the modern systems. Oh, microservices, let's just decouple everything, or Kafka and everything. That's modern systems. But I think it's to your point, what you're trying to make is like all these tech systems are evolving, right? Like in your 25 years of career, I mean, it's fascinating for you to kind of experience all of that, right? I mean, I don't know, you didn't even mention this, but 2007 and 8 is when that Dynamo paper came out that led to the beginning of what was it, Cassandra, and then you have a parallelly, while on the infrastructure side there are these changes happening. On the database side, you're going from relational databases to NoSQL databases, graph databases, and then now we are in this era of distributed SQL. I mean, and now we call distributed SQL as the modern, database. So yeah. So it's pretty interesting.
Yeah, I mean, you just sort of shift to different problems. I think like we used to worry about, I don't have room in the data center. I don't have time. The servers are going to take 6 months. Can I rush them and get them here in 3 months? Now we spin things up in 10 minutes, but then you have other problems. You start. But I think you try to spend more time focusing on the things that really drive business value and less time thinking about the plumbing. And what can I do in the system to really drive shareholder value or You know,
Yeah, and I think the thing is, these systems had to change because the business expectations and the user expectations changed, right? Like, I do not know how it was in America. I grew up in India, and we have said this before on the podcast that we would have to like book a train ticket. And that in 2006, the only way to get a train ticket in India was you would have to physically go to a train station at 4 a.m. in the morning and wait in line to, get a ticket that was after 60 days. And then that evolved to by 2012 or 14, we started getting these websites where you could, but you would go to these websites right at like this time when the tickets are open, but the system would go down. Like, and we people who grew up there were so used to living in this time that, oh, well, the website is down. And that was okay for us. But now it's like table stake. You can't have these systems going down. Even that's the same trend in India. People are like really upset, and they'll just talk about it. But I'm pretty sure in America this change came way sooner, like in 2008 and 9, 10. How was it here for you? Like, when it came to modern systems?
yeah. I mean, I think I've got like kids that are in their teens and early 20s now, and occasionally I'll be talking about something, and they're like, "What are you saying?" I'm like, like how we used to have to dial the phone by like turning the thing, and they're like, "What are you talking about?" Like those things come up kind of more and more recently. My wife and I found a speak and spell at a garage sale recently. When I was showing my kids, yeah, I don't know, when I was a kid, like this, they had this little toy called a speak and spell, and you could like type in a word, and it would like say it to you, and had these games, and it was a huge toy, and like, and I look back on it now, and I'm like, that's like every that's like the most basic, little app in our phone now. And I was trying to tell my kids this thing was so cool, and they were like, what why is it that cool? um,
Hey, the kids who played Nintendo will never get this, man.
yeah, yeah. I mean, our expectations just change, and um, I think the things that used to be a challenge, you'd solve those, and that you got a sense of accomplishment out of that. And now those things are like nothing anymore. And then you got different things to challenge, but you still get a sense of accomplishment out of that. So you just sort of shift focus over time.
Yeah, no, I agree. I wanted to go into like some of the things that you mentioned, right? Like these systems that you used to work on, and the whole idea that over the years, the cutting edge systems have kind of shifted to being something that we are so used to now, like it's readily available. Now let's narrow it down to your career in the last last decade at least, right? And you've worked at some really interesting companies. Tell me a little bit about what do you feel is modern looking like in the next 5 years, right? I know you've worked 4 years ago. You were working at a company that was a NoSQL database. Now you're at a company that does distributed SQL database. That both are like focused on resiliency and helping folks modernize their legacy systems in different ways. But where do you think it's all going?
Um, yeah, well, I think cloud is definitely here to stay. In my current job, I talk to a lot of companies, and it's interesting that if you talk to like new startups, everything they do is in the cloud. Like the first app they ever built, the main thing that they do, or they just say, oh, I'm building it in the cloud, and they just kind of build it in a cloud native way, and that's that. And then if you talk to us, an established company, bank or a insurance company or something, like they're like, hey, we've been running Oracle for 40, 50 years, and our whole infrastructure is based on this idea that we have two big data centers, maybe in the East US and the West US, and or we've got two data centers that are like 100 kilometers apart, and they're far enough to maybe not get hit by the same tornado, but they're close enough where I can do some have some reasonable latencies. But they're kind of entrenched in that world, and that's how the world did forever. I mean, I think when I was at Western Union writing big systems, we had our active system in one data center, we had our passive system in the other data center, and twice a year we had to go through a DR test, and they say we're gonna in production we're gonna switch it over to the failover, and like it never went well because but in the last 6 months you would have changed the firewall thing, and you remembered to change it in the active side, but you forgot to change it on the passive side or whatever. So it was always like, oh, it didn't work, and then he'd fail back, and then he'd fix the other side, and so. But I mean, the point of that was like force you to do it in production, so that if it ever really happened and you lost one
You know
side,
how to do it. Yeah.
yeah, but it was such a pain, and so I remember after that working with another company, and they said it was a big company. They said the way we run is our databases are active, and our apps are active passive, and we can switch all the traffic from going to one side to the other side by flipping a load balancer, but we don't want to have to coordinate. If I flip the traffic from the west side to the east side at the app layer, I don't want to have to coordinate that with the database. So the database just needs to be active. I can write to either side and it'll go to the other side. And I started digesting that. I thought, wow, that's really smart. And so and I've worked with companies that say every week we run traffic on active, and we split it between two sites, and then we'll force it to go to one side, and then we'll force it back to the middle, and then we'll force it to go to the other side. And they just do that constantly. Like every couple of days they do that. And so instead of doing it twice a year, they're doing it all the time,
Right.
But
what was the advantage when they did that?
Well, the advantage is, if you're in the app active passive, so all your writes are going to one side, then your database is acting active passive. I mean, you're doing bidirectional replication, but only thing going across the pipe is from the side that's taken to the writes to the other side. So functionally, it's acting like an active passive. But then if you want to switch the database, the apps, you just switch the apps, and all of a sudden the writes are coming in over here, and the database, it didn't change anything, but now all of a sudden, all the writes are flowing across one way. So even in systems where like you don't want to deal with conflict detection, like in that kind of scenario, you only have conflicts just in that little window when you first switch it. So it's a very kind of operator friendly way of, you feel good about, like, I can just flip the traffic with this load balancer, and everything else in the infrastructure is going to work.
But somebody has to be involved in making that switch happen every other day, every 2 days.
Yeah, well, at the load balancer level, they do.
Yeah. Okay.
And it also means you have to size like both your data centers to handle the full amount of traffic. So at any given time, you're kind of underutilizing. But I've always thought that was a smart way of doing it, and kind of a modern way for the time. And you could do that with Oracle Golden Gate or IBM DB2 and QRep, or you could even do it with SQL Server and like merge replication, or different technologies you could use for that. So, but even that's sort of a DR way of thinking. Even if it's you're not doing a once a year or twice a year DR test, you're still doing like a every other day DR test sort of thing. And one of the things I like about Cockroach, and I'm not here to give you a Cockroach ad, but is we kind of shift some of the capabilities in the database, shift you away from thinking about disaster recovery, and you just think about disaster avoidance. So like one of the main tenets in, if you're running multi-region in Cockroach, is we run across 3 regions, and then we'll spread the 3 replicas that we create across those 3 regions. And then you can lose an entire data center and you're still up and running. And if you want to, you can shift the apps to try to write to another data center. But you're not thinking, oh, the one region went down, I gotta go page everybody and get on a Zoom call and try to figure this out. It's just automatic. And so, yeah, so a lot of, interestingly enough, the newer companies that are kind of cloud native and kind of grew up in the cloud, that's a very easy concept for them. They're like, oh, you want to start our apps in 3 regions? Great. Click, click, click. We got 3 regions. And the older companies are like, no, I've got these 2 data centers I've been using forever. I don't want to run in 3 regions,
This is what I wanted. It's a good segue for me. Mike, one question I wanted. Do you think the reason why many of them want to stay to DC is also, like, while I understand there's a cost involved to like having a new region and all that, but do you think it's also like cultural, where they're like, well, we've always done 2DC and we'll just stay 2DC?
Yeah, I think so. I mean, some organizations say we're we're not ready to go to the cloud, or we're not ready to take all our systems to the cloud. Maybe the more the mission critical stuff, or the stuff that deals with personally identifiable data or PCI data. That stuff we want to keep closer to the vest. So they're still kind of working in their own data centers, but yeah, I think especially if you've got a lot of relational database where the norm is to run it, have an active and have a passive, or have two DCs and do active, but like you can't even do a third one. That maybe you could, but it'd be kind of ugly to deal with all the conflict resolution and all. And so, it's just not something that like people even kind of get their brain around.
Yeah, it's interesting. Let's talk about it from this angle. Like, you brought up a really good point, and I think that's a good way to position it. It's disaster recovery versus disaster avoidance. What is it that you care about most? User, customer, that kind of thing, right? And it's a very good, a very wise way to present the contradictions to somebody and say, okay, choose this or choose this, right? But in 2010, when you were working on a legacy system, like say it was SQL Server or something, suddenly you got introduced to a Cassandra, and it's an active actor system, and you're writing everywhere, and it's so fast. You're like, oh, so what do I have to let go? Okay, I just have to denormalize all my tables. That means I let go of my joins. I let go of all these things, but I get all these things. So the world kind of created something to solve something at that point of time. How was that shift for you to leave denormalize schemas and come back to the world of you know where consistency exists?
Yeah, that did happen to me. I was a guy that I loved relational databases. I still love relational databases. And to me, it's like, modeling your data first and understanding the relationships in your domain makes a ton of sense. And then, figuring out the queries and how you want to use the data later, and that works well in small systems, and SQL Server and Postgres and all, they work well in small systems. And then, you just think, what else do I need? This is like the Swiss Army knife of databases. It does everything I need it to do, until you get to a certain scale. And the first time I ever really got to that scale was at Western Union, where I think the data size of the database had gotten to 5 or 6 terabytes, and all of a sudden, like things started to get harder. Backups got harder, and doing replication got harder, and certain tables, you start to get to the point where you're saturating memory, and you can't get the SAN any faster, and you can't get any more vCPUs in the machine. So you run out of like vertical scale room. And so, yeah, the first time I ever heard about Cassandra was when I was at Western Union, and we were thinking, I remember we had the system, running pretty well. And then the guy that led the business unit that we were supporting said, he caught me in the hallway one day. He's like, oh, by the way, we're doing this thing, and we expect the volume going through the system to increase by like 20x. So I just want to give you a heads up so you can handle that. And I was like, okay. And inside I was like, oh, I was freaking out, because I was like, 20x, like there's no way. And so we started looking into what else we could do. And I discovered Cassandra, and I first looked at it and I thought, oh, I don't know. That seems like a big shift. And so we didn't go to it eventually. But a couple years later, after I'd gotten more comfortable with it, I was in another position at another company where I was trying to do this system that needed to scale to this kind of crazy degree. And I tried to do it in SQL Server, and SQL Server just kind of fell down. And so I started doing I'd heard about Hadoop at that point. Like, I was like, what is this?
Yeah, this is a great 2013, 14 era.
Yeah. And I was like, Hadoop and big data I started hearing about. I was like, what is Hadoop? And I kind of figured out it's like a way to scale out to handle like ridiculous amounts of data. And it was mostly for analytics. And I wasn't doing analytics. I was doing like OLTP stuff. And so from Hadoop, I discovered HBase. And from HBase, I kind of got reminded about Cassandra. And so I did a proof of concept with Hadoop for the system, or with the HBase. And then I did one with Cassandra. And we ended up doing that system in Cassandra. But yeah, Cassandra was like, okay, take everything you know about databases and just sort of break it all in your head. And it's like, and it like, some of it was so hard for me, because it was like, hey, we can scale as big as you want. We can handle as much volume as you want. You just can't do joins, and you can't do foreign keys, and you have to denormalize your data, and you have to handle isolation in the app layer, and you have to handle consistency somewhat differently. But as long as you're willing to make those trade-offs, like, it's awesome.
It's cool. Yeah.
Yeah. And so part of me was like, oh, you mean, what do you mean I can't have foreign keys? Like, I love foreign keys. And so, I'd kind of learn that, unlearn that. And I figured out how to kind of do things the Cassandra way. And you can do tons of stuff in Cassandra. And for certain use cases, it's an amazing tool. But yeah, eventually I'd lived in that world for about 4 or 5 years. And then I heard about Cockroach. A friend of mine had gone to work for Cockroach, and he's like, hey, you should check this tech out. And so I started playing with it on the side, and I was like, oh, this is cool. It means I get the relational modeling and I get foreign keys and all that stuff I love, but I still get this horizontal scalability. I was like, that sounds too good to be true. I don't think that's
true.
I was like, I've had this like drilled into my brain from working with Cassandra. Like, you can't do joins, you can't whatever. And so I started playing with it, and I realized this actually works, And so that was kind of my
your moment.
My moment for saying,
yeah.
I think I want to work with.
I had a similar moment, right? Because I know you and I spoke about it after you moved to Cockroach, and I was like, oh man, I'm still in the Cassandra world, but I'm slowly like watching a bunch of my friends start using. So you remember I told you like I was working on an app and use case personally, and I was trying to get Cassandra to fit. I would just not fit because I need joins. I needed to reference something in another table, and I was like, man, I don't think this is going to work. And so I think naturally the world kind of got around to the point that we needed a system that could do what we wanted, but it just came 10 years late, like that kind of thing.
Yeah. I remember when I researched Cassandra at first to do that one system, I found a few other systems that claimed to do it and said, oh no, we can give you the joins and we can give you it all. And I tried them. I tried a few, and they didn't.
What was it?
They didn't work. Well, I remember with HBase, there was a thing you could put on top of it called, I forget, like Falcon.
Was it Pig?
Huh?
Pig?
No, not Pig. It was, I don't know, but it gave you the ability to do joins. And then I'm not sure I remember the other one, but there was a similar kind of thing where you kept it relational, and it has ability to scale. But I tested it, and it fell down at a certain point.
Right. I mean, what you're saying is like, in many ways, that era of big data, nobody says big data anymore. Have you noticed it?
Yeah.
Like, we don't say big data as a term, but that was such an industry term. Like, now big data has been replaced by multi-region, like a high availability.
Yeah, or AI. You can't do anything today and not work the words AI into it.
Not word AI in it. Next day you and I will have like AI Jim Hatcher and AI.
Yeah, I'm gonna get it tattooed on my forehead. So
no, don't do that. But the reality is like, what I wanted, like my segue to it was like, when we were talking about these modern systems, all these systems try to solve a particular problem, but I think we've naturally reached a point where user expectations are like low latency, high performance, high availability, and they want this to be consistent, right? And I think there are a lot of players in the database market doing that. And you naturally arrived at a point where like, oh, I've tested all these databases, all these different tools, and my 25 years of career, and now you're like, I like what I'm doing with CockroachDB here. So tell me a little bit about your customers who you have interacted with, and from their perspective, when they shift towards Cockroach and CockroachDB, and how do they experience it? What's like something that they are shocked to hear about or experience?
Well, I think the really the reasons people turn to Cockroach, in the name Cockroach, there's the idea of resiliency. It's kind of a playful way to say we're like the most resilient database, because obviously if you they say you can't kill the cockroaches if there was a nuclear fallout, the cockroaches would survive, right? So the technology of Cockroach, it's scale out, so there's lots of servers involved, so you're not relying on one server with one memory space and one gateway switch coming in and one power source or whatever. So as soon as you build a database that can work well across multiple nodes, you've kind of broken the original relational model. If you look at early Oracle or SQL Server, whatever, that was part of the idea behind relational databases. I can give you strong consistency, I can give you ACID guarantees, I can give you referential integrity and uniqueness guarantees and all this. And the way I do that is you put everything in one server, and I can control it all in one server, and I can do joins because it's all in one server. And the data in a third normal form model, any piece of data is in one spot. And so when you want to change that thing, you seek to that spot, you lock it, you change it, you unlock it, and then the next person to join the data gets the right thing. And so, having a system that guarantees your referential integrity and ACID guarantees and all that, but I'm going to work on multiple copies of the data. It's like, what? How does that work? So, anyway, but I guess my point was because we have multiple copies of the data, there are some inherent, capabilities that come with that around resiliency and availability. So, we replicate any piece of data 3 times, and we only need 2 of the 3 copies available to be able to read and write. So that means a third of your infrastructure can be down, and you're still serving your customers, serving your apps. So I think people that, most people that really kind of buy into Cockroach, they're saying, hey, I've got this mission critical app. I need it to be resilient. I need it to be available. I also need consistency and the guarantees that relational database gives me. I just need a higher level of resilience and availability. So, so, it's often like financial services, people doing financial payments, people doing, e-commerce inventory, it's systems that are large enough to need scale, but also they're like, the way their business model works, they need strong consistency. So, when we work with customers and they want to evaluate Cockroach, we always say, let's do failure tests. Like, let's spin up the cluster, let's run a workload against it, and then let's take a region down and see what happens. And let's verify that Cockroach works the way we think it should. And make sure that your app handles it okay. And I've had some heads exploding kind of moments when I realized, oh wow, we just took a whole region down and the app just kind of kept on going.
Yeah, I don't have to deal with the ticket.
Yeah,
somebody can just deal with it, and the app just handles it. Wow.
Right.
Yeah.
So that's there's some people that say, hey, look, I got a workload, and I can deal with eventual consistency, or I can deal with maybe it's a tier 3 or 4 system, and if it's down for a couple hours, no big deal. Well, Cockroach is probably overkill for you. Maybe not, but I think the people that really get the value out of it are like, I need that high level of, I need 5 nines. I need, to be always up, never down.
Yeah, no, I agree. I think what I've noticed in my conversations with people is also this moment where they're like, what, we just took a node down and a region down and it's all working fine. Wow. Okay, this is fantastic. And the next thing they ask me is that, hey, how much can I push into the system, right? Like how much can I scale? Or what are my limitations? Because when you say, hey, this can scale horizontally, they don't believe it. They're like, oh, you're just saying that because that's marketing. I'm like, no, man. Why don't you just, because I remember you recently you ran a test or something, right? Where you a few months ago, you're like, oh, we'll just double this and you'll get double the performance.
Yeah.
You want to talk more about that?
Yeah. I think when you work with Cockroach a lot, you kind of get numb to some of this stuff, like how cool it is. So, I think the other thing is everybody says they're resilient and everybody says they're available. Oh yeah, we have HA, we have whatever. And I think we ought to call ours ultra, super, uber, crazy resilient, because it's, for one thing, it's just built in. You don't have to configure anything else, and it just works out of the box. And anyway, but I've worked with a couple customers recently who've had very aggressive throughput needs, and they say, my average throughput is X and my peak throughput is Y, and I want to, I either want to be able to scale up and down or scale in and out to handle the difference between my average and my peak, and that's kind of impressive when you can show that. But another one, we said, we're going to hit, you got this huge throughput target you want to hit, and let's just hit, a tenth of it, and then we'll double the cluster, and okay, we'll hit. Look, we got 20% now, and then you kind of continue out and show that you can scale out, and you get near linear you keep performance the same with near linear growth, and yeah, so it's can be kind of dangerous because you're like you could either kind of fix your code to make it more efficient, or you could just throw more hardware at it.
It depends on how much dollar you have in your pocket.
Right, like if just like Cockroach handle that for me, but
I know.
like I'll come back and fix it to make it more efficient later, but horizontal scale can kind of help me skate by in the meantime, and then later
Yeah, that reminds me. I worked with a customer this year. It's in retrospect, it's one of the best deals I worked on. I can't tell the name of the account, but when we met them, they were like, "Oh, this is a workload right now." We're like, "Oh, this is good. Well, just these many numbers are." They're like, "Oh, yeah, but we need to do a 10x test." I'm like, "Oh, you want to do 10x? Okay, cool. We'll do 10x." Okay, so they push from 1x to 2x to 4x, and then they go to 6x. And then the cloud provider tells them, we have no more we have no more servers left in this region because you've already used everything to hit 6x. And they saw the 6x in like a 3-hour window or a 4-hour window. They were like, oh, this is phenomenal. This is exactly what we need. And so for me, who has worked at this company, who always has to say that, oh, we have a great product, for me, it was an eye-opening moment for me to see like a test like that and customers saying, okay, you guys work, we don't have any more hardware left. We need to there are other teams in the company who want these servers. We're going to relinquish all of these servers and give it back to people. That was a really cool and good, interesting moment for me to see this year. It was pretty fun. Yeah. Anyways, from that, I want to segue into something. Where do you think modern systems are going now? Like everybody's like, it's not like everybody has started moving to these multi-region, single-region setups that are highly available. With Cockroach and what you have been seeing in the market, where do you think everybody's going now?
Well, yeah, I think people are like everybody I talk to is in some type of cloud journey, and they might be early on or late on, but some folks are saying, hey, we're just trying to make ourselves cloud ready. So if we want to move to the cloud, we're already kind of in that zone. And some people are, you hear the terms cloud native or cloud first. Like, we're like that's the end all be all right now, is to kind of be cloud first. So I think we'll continue to see that, like some of these concepts of containerization and microservices, and the way we do ancillary services like logging and gathering metrics, and we'll continue to make those more and more cloud native, and they'll be more and more transparent and kind of turn into like commodities. But I also think we'll continue to see more people taking advantage of multiple clouds. I we talk about that some at Cockroach. Like, Cockroach can do some of the same things that things like Google Spanner can do, or Azure Cosmos, but we can do them in any cloud. And so I used to use the term we want to avoid vendor lock-in, and I've stopped using that term because I'm not sure that really says what I want to say. I've started using the term cloud portability.
Like, cloud portability, yeah.
I want to have a workload that if tomorrow the CIO calls me up and says we're shifting everything from Google to Azure, like I'm not gonna be like I'm using all these native services. So I'm definitely starting to see that more. Like some companies actually want to run multi-cloud, where they've got a single database that spans hardware across multiple clouds. I find people actually do that not very often. They like the thought of it, but when it comes down to actually implementing, it's kind of tricky, and there's egress costs involved. But I do find that people want the ability to say, hey, we're going to run in AWS today, and if somebody says, hey, we need to switch over to Google, I can do it in a week or something. Give me a week and I can have everything moved over. And I think people like that idea because it gives them some leverage in negotiations. But it also means, if something happened, and we some of these companies have such a reliance on their cloud providers right now that if you're a company providing sort of critical infrastructure to the country or something, and you're depending on AWS, all of a sudden AWS is critical to the country. You think about like.
No, I agree.
Yeah, I mean,
Yeah,
so
no, I've not thought about it like that, but when you put it like that, there's a lot of thought to it, right? Like the fact that cloud portability is the right term. Why would you want to design a system where if something happens and say AWS cannot deliver, you are stuck, your business is stuck, everything is stuck there. But you can build on technology that is provided, that is easily cloud portable, right? You can move from one cloud to another. It's super easy, and you're back in business, right? You can negotiate your contract. It allows you. I think that freedom is very important. I don't think many leaders in the industry understand that, because they don't make the decisions at a tech level. That's just my opinion, but this is where we throw some opinions out there.
and you talk to folks and say, look, we're always going to be in AWS. Like we're just this, we've signed a big contract and it's a 10-year contract and whatever. And so I think, yeah, maybe you will always be in AWS, but I've been doing it long enough where I've seen somebody say we're always going to be in AWS, and then a year later they have a new CIO, and CIO likes Azure or whatever, and he says, "Look, I can save the company $100 million by switching from Google to Azure or whatever it is," and then all of a sudden, you're not there forever. So I mean, I think using the clouds as commodity makes a lot of sense to me.
Yeah.
Just
In that scenario, I'm a very imaginative person. I imagine that DBA and those engineers were like, all right, December 31st, they send a mail out. All our systems are up and running on AWS after this 3-year migration. We finally moved here. And then the CIO sends an
right.
email. Right, you're moving.
Yeah. I mean, I've seen it a few times at really big companies, and you think,
Yeah. And the
somebody's in there.
engineer is like,
Yeah.
I can't have a life, man. I'm just all my life I've been doing migrations.
Right. Yeah.
You meet this guy, at like
Right.
a pickleball event or something, and you're like, hey, what do you do? Like, hey, man, I've been just doing migrations for the
Right.
last 6 years.
I'm the guy that integrates all the stuff that the CEO brings me. Yeah.
Yeah, like the CI, he's like, we are concerned that our egress cost is too much, so we'll just we'll just migrate everything over. Anyways, yeah, I mean, this is really awesome, man. Like, I mean, you have so much experience doing this. What gets you going every day? Like, what excites you to come talk to people and talk about technology? You've been doing this for 25, 30 years, and in many ways, I have to say this out publicly. Jim has been a very influential tech person for me in my career, because I think when I moved to DataStax, so that was Cassandra. Jim was one of those people I would go talk to every day, and I would see your passion, and that kind of stuck to me. But you've been doing this now 25, 30 years. So what's keeping you doing the next thing? What's exciting you?
Yeah. I mean, I definitely like working in the data space. I mean, I don't just love tech for the sake of tech. We've talked to before, like, there's some apps that you work on and you just feel like it's plumbing, like I don't, but I do, I think part of the reason I like database is like, it just appeals to my sort of puzzle solving brain. Like I like to model things in a certain way that just kind of feels like it all comes together. And then I like to do database tuning, and oh, look, this query used to take a second. Now we got it down to 12 milliseconds or something. It's very satisfying. And in the sales world, I mean, I don't build things anymore, and I think I used to get a lot of that from building things, but now I kind of come alongside other people who are building things, and they say, I've got this problem I'm trying to solve, and you can say, hey, look, let's talk about, Cockroach might not help with that, but Cockroach might help with it, and you can kind of sit down with them and figure that out, and it's cool to see, like, some companies, they'll come in, they never heard of your product, and then you said, hey, I think we could really help you, and then you come in and help them, and then over time they get so good at your product that they're like teaching you stuff like that's pretty satisfying. But and I like mentoring people. Like I think that's one of my favorite things about working on the team is, like, I like coming alongside new people and making sure they kind of learn the tips and tricks that make the job, a bit easier and better. And so,
Yeah, that's awesome, Dad.
yeah.
Dude, it's like I said, Dad, I know we'll have to edit that one out. That's awesome, dude. But what I was saying was, next year, 2025. It's been a great 2024, right? So what do you predict? Do you think we're going to be talking more AI, more quantum, more databases, or more crypto?
Yeah, I think AI is the tidal wave right now. I mean, you continue to see it in more and more and more things. I listed something on eBay the other day, and it was like, "Do you want to use AI to make an item description?" I was like, "Yes, I do." Okay,
Oh my God.
and
Dude, but it is fascinating. I do not know if you followed the news today. NVIDIA's CEO just launched a new computer for $249. It's called Jetson Nano. And the whole idea of this particular new computer is that you can run a large language model, large language model on that machine. It's a small box with a big vent of fan on it. And it looks like a Raspberry Pi. It's $249. So it's like talking about AI on the edge. Now think about how many systems will then have to support database on the edge to support these large language model queries. So it's going to be a fascinating year in tech, I feel, next year. So
yeah, no, yeah, it's just you can't get too comfortable with things in this industry, you know. And I think one of the best ways to stay on top of things is to have a job where you work with a lot of clients, and you're constantly seeing new clients and like, oh, what are you guys doing? That's cool. And
I know.
kind of,
But I also feel, don't you feel like sometimes these clients are like so distracted because there's so much information coming to them, and they're doing something. It's like they become like a toddler who's so distracted by, hey, try my technology, try this technology, and while they've made a decision, they're like, oh, well, let me change it up. It's like it's like my 6-year-old girl. She's like constantly like, I'm gonna do this.
yeah. I mean, you got to have a team these days. I mean, just no one person can do it all out. You know? Yeah.
Well, it's been a pleasure having you on the podcast. I'm very glad that the Texas Pros finally made it to the big ideas. We made it happen, and I'm glad that you could talk about modern systems and talk about a little bit more about your career. Before you go, I wanted to see if you'll sing a song for us with your guitar or the degree that you did not pursue. We'll see if you had learned any music theory. No, you don't have to do that, but. Do you have any great plans for the holidays?
Just gonna kind of try to recharge the batteries. The rest of this week, I'm trying to get some more stuff done from work, and then sort of turn off my work brain and try to focus on the family. And got some few relatives coming in that I'm excited to see, and so just try to focus on the season and be be in a place of gratitude.
Yeah, I think gratitude is very helpful, especially end of the year when you're like, oh man, I survived another year. Okay, let's go 2025. For everyone else who joined, I hope you enjoyed listening to Jim Hatcher, the one and only, about half of Texas Bros. So thank you, Jim. Thank you for coming.